Okay, so we're looking at a Pascal's triangle question. So I'm going to read it over first and then kind of try to tackle our 7a. A checker is placed on a checkerboard as shown. So here's our circle. The circle is the checker. The checker may move diagonally upward. In other words, we're going to assume upward is this direction, and it can only go on diagonals. In other words, it cannot touch any of these green spots here. It can only touch the white spots for now. Although it cannot move into a square with an X, these are no good, the checker may jump over and into the diagonal opposite square. Okay, so what we're going to do here is we're going to try to draw a Pascal's triangle within this checker box. And the question asks is how many paths are there to the top of the board? In other words, 1, 2, 3, 4. How many different ways can you get to these 4 endings or these 4 slots at the end here? So we're going to use Pascal's triangle. If you remember, Pascal's triangle is kind of set up where you have 1, 1, and then the way you build a triangle is you just add values in between. It's always 1 on the outside, 1 and 1 is 2. 1 on the outside, 1 and 2 is 3, 3, 1, 1, 4, 6, 4, and you kind of continue all the way through. That's going to also tell us how many roots there are to something. For instance, if I was in some type of triangle and I needed to get to this square here, well, this is telling us there's 6 different roots. I can kind of go 1, 2, here's a root, here's another root, here's another root, here's another root, here's another root, like this. So they're telling us there's 6 options there. So whatever number we're going to get to here at the end, that's how many options there are to get to that square. And then because there's 4 squares we can reach, we're going to kind of add up our options to figure out how many different ways we can get to the top of the board. So let's start off. Well, I can only go to this square one way and this square one way. And then to this square, same idea. There's 1 root, 2 roots here. Now I can't get to this X, but I can jump over it. Still only a 1, okay? And still only a 1. So I can really only get across 1s this way. It's all these numbers in here that we're going to add up to kind of figure it out. So to get to this square, well, 2 and 1 is 3, okay? 2 and 1 is 3. We want to, now technically there would be a 1 outside here. And I'm going to continue this triangle because it's going to help us calculate these values in here. To get to this one, this would have technically been a 1. Okay, so what's happening here though is normally we'd say there's 4. You go 3 and 1. There's 4 roots here, but this root is blocked. We can't actually get to this value because we can't take this X. So I no longer add this 1 value on the side. There's still only 3 ways to get here. Okay, which is a little different from what we're used to calculating with our Pascal's triangle. Same with our X here. We'll calculate this one, 1 and 3. This will give us 4 options to get to this guy. But again, because I can't go outside of the board, that 1 doesn't really count. So again, there's only really 3 options to get to this square. We're still taking that same route. We haven't added any more roots. To jump over this would be like saying 3 and 3 would normally give us 6, but we're not quite there. We're going to jump over this. Let me quickly, because we don't have an actual value for X, this square here, think of it like you're adding this guy because he's directly diagonal, and because this X doesn't count, this 3 would be directly diagonal to that square. So we'd add up these values. This 3 and 3, that's going to give us the value of 6. So there are 6 roots there. Same idea with this square here. This 3 is directly diagonal. And then because this X doesn't count here, this 3 is directly diagonal. So we add up this 3 and we get 6 options to get to this page. And then now that we've jumped our X's, it's the same idea. 3 and 1 is 4. There's 4 options there. To get to this square, there are 5, 10, 12. And here, now normally again we would have went out 1. This would have been the number 4. Out 1 again. This would have been the number 10, but these 4s don't count. There's no other extra root, so this is going to be the value of 6. So we should be able to add our way across here to find out the number of values. So 10 and 12 is 22, and 11 should be, I'm getting 33.